We're going to look at factoring today. Factoring is a huge word in mathematics that defines many different types of the same thing. Factors are two things that get multiplied together. So factoring is the process of making things that are already multiplied together into those smaller parts that got multiplied together to be them. It's like taking 6 and saying 6 is 2 times 3. Making a factor tree. Making prime factorization of something. 2 and 3 are both prime numbers, the smallest numbers that can multiply together to be 6. So that's part of factoring, is breaking something down into what multiplies together to be it. This comes, what we're looking at, from the distributive property. So when you use the distributive property left to right, you just distribute, just like we're used to. X times x plus x times 5 is x squared plus 5x. We're used to doing that. We're used to doing this in a bigger fashion, multiplying through like that. What lets us do that is that we can use the associative property, maybe, of addition to change and group inside of the first set of parentheses. So changing the first set of parentheses to brackets so that we can group the 2x plus 3y together and put, now we have two grouping symbols, but then you can use the distributive property to say, oh, now we have two things. The 2x plus 3y is one thing in grouping symbols, so we can multiply the 6xy by it. And the same way with the minus 4. Then you can do the distributive property again. So 6xy times 2x plus 6xy times 3y. And this is what, of course, lets you just skip these steps and go straight to the multiplying like we're used to. Just saying, oh, 6xy times 2x is 12x squared y. 6xy times 3y is 18xy squared. And 6xy times minus 4 is negative 24xy. So that's using the distributive property from left to right. But what about when you use it from right to left? So going from this side of the distributive property back to that side of the distributive property. This is what is commonly called factoring out the common factor. So when we look at x squared plus 3x, we want to find the a in that right-hand side, ab plus ac. And so we're thinking of x squared as x times x. And we're thinking of 3x as 3 times x. So that we can see, oh, 3 times x is really the same as x times 3. Multiplication is commutative. You can switch around its order. So that they have an x in common. That x is the a in the right-hand side, ab plus ac. And so when we're going to the left-hand side, you're factoring out that common x, which leaves you with what isn't in common, the x plus 3. That's factoring out the common factor. So in the first term, you have x times x. In the second term, you have x times 3. So a is going to be one of these two x's, while b is the other x in x squared, and c is the 3 in 3x. And so when we're doing a b plus ac, we do have x times x plus x times 3. But we know ab plus ac is a times b plus c. which is x times x plus 3. Sure. Using the property is always more complicated than just looking at it and factoring out the common factors, seeing what they have in common and factoring it out. So much so that most people don't really get that we are using these properties. These properties are where this comes from. It's not a magical math thing that happens. No, it's just using the property from the right-hand side back to the left-hand side instead of the way we're used to using it from the left-hand side to the right-hand side. Common factors. Before you factor anything else, always look for a common factor. This is going to make your rest of the factoring that we're going to do much easier if you have the common factors already factored out. A common factor is a monomial that you can divide all the terms by evenly, also known as the greatest common factor, hopefully. Step 1, we do in our head. We break down our terms into the primes. This is the step that you want to be doing in your head. Do it as scratch work. It's just something that happens so you can look at it and factor. Step 2, look for what all the terms have in common. Figure that out so that you can group them together. And then step 3, factor that common term out, which means put one copy of it on the outside, and then what they don't have in common goes inside the parentheses. So what this looks like in example A, you just look at it and you factor. Those things have a 2 in common, so this is going to be 2 times 5n plus 3. What I did in my head was I said 2 times 5 times n plus 2 times 3. I look for what all the terms have in common. They have a common 2, so I'm putting one copy of the 2 on the outside, and then what they don't have in common goes on. That's just how easy it is. You can look at it and factor. The stuff that goes on your head is stuff that goes on in your head or is scratch work, and you just have to hope you aren't getting that wrong. You're not in Algebra 1 where we expect you to get that wrong. We're in geometry where we expect you to get it right at this point. Factoring out the common factor is not supposed to be a big deal. Hopefully you've thought about it like this before, and it's just something you can easily look at for common factors and do. So, example B, 4c squared minus 12c to the 5th. So we're factoring out a 4c squared, which leaves us with 1 minus 3c cubed. Again, what we did was he said we have 4 times c minus 4 times 3 times c times c times c times c times c. c to the 5th power, 5 c's multiplied together. So we have a 4c squared, 1 4 and 2 c's multiplied together that they all have in common, which is going on the outside. But then since we're multiplying, what is this 4 times c in the front part multiplied by? There's still a 1 that's out here being multiplied by it, which is what's left over. That's why that 1 is there. It's a placekeeper of the 4 times c times 1. And then 3, there's 3 c's being multiplied together for the c cubed. 9, h squared k squared minus 12 hk squared plus 24 h cubed k. So they have a 3 hk in common, which leaves me with 3 times h times k minus 4. We already factored the h out, so k plus 3 times 8 is 24. H squared. Try that grouping on your own. If it's confusing or you're getting a different thing, let me know. We'll go over it. Factoring initially gets used for solving equations. It's one of the first things we do with factoring. We do this with the zero product property. If a times b equals 0, then either a equals 0 or b equals 0, which is the way of saying if two numbers multiply together to equal 0, then either one of them is 0 or the other one is. It's the only way two things can multiply together to equal 0. So we use this with factoring to solve. If we can get our equation equal to 0, factor it, and then set each of those factors equal to 0 with this zero product property, we have two smaller things which we should be able to solve. And so the first thing we've done so far is just factoring out the common factor. We look at x squared minus 9x, say they have an x in common, and we factor out that common x. Now we have two things multiplied together to equal 0. So our two things that are being multiplied together here are x times x minus 9. So x is the a. If two things multiply together, either one of them has to equal 0, or the other one does. The other thing that's being multiplied together there is the entire quantity x minus 9. So that entire quantity equals 0 is the other one equaling 0. This one is already solved. X equals 0 is a solution. It makes that equation true. This one we know we can add 9 to both sides. And there's our second solution, x equals 9. Those are the two solutions for x squared minus 9x equals 0. So in B, we factor out the common 5, and we get x squared minus 1 equals 0. But x squared minus 1 is a little tougher to do. There's a couple things we could do here. We're going to use our zero product property to say 5 equals 0, or x squared minus 1 equals 0. Does 5 ever equal 0? No. 5 and 0 are not equal. It does not give us a solution. So looking at the x squared minus 1 equals 0, we can add 1 to both sides and get x squared equals 1. And then we can take the square root of both sides. When we take the square root, we don't know whether we get a positive or whether we get a negative. And so the square root of x squared is x. The square root of 1 is 1. X equals 1 or x equals negative 1 are our two solutions here. This x squared minus 1 is also something that we can continue to factor if we know how to factor. So the first part of factoring is factoring out the common factors. That's what we did now. Part 2 of factoring, the next video you get to watch today, is factoring trinomials, is how most people think of it. It also picks up binomials just fine. So take a break, digest this, and then watch Factoring Part 2.